Right, so in this video I'm just going to have a look at some general uses for this formula here. So I'm just going to do 2 or 3 examples where we can use this formula, and it's the distance from a point to a line. So if you want to find a perpendicular distance from a point to, from any point to a straight line, we can use this formula here. So I did a derivative of this formula in a previous video, so now we're just going to have a look at using it. So let's start off with a straightforward example. So we have a point, let's say -3, 7, and we have a line, a straight line, which is 5y is equal to 6x plus 2. And we want to find the distance between this point and this line here. Well, what we do is we say this here, this point here, we call this x1, y1. So -3 is x1, 7 is y1, and we're going to put those in here and here. Now this really is our equation of our line, so we just got to rearrange this here so that it looks like that. So let's see, we want the x first, so that's going to be 6x. Then we want the y next, so that's going to be -5y, and then we have plus 2, and all of that is going to be equal to 0. So this is what we're going to put on our top line here. Okay, so let's do that. Distance d then is going to be the modulus of, well, we want ax1, so remember a here is 6, our b here is -5, and our c here is 2. So I'll just write that in actually. 6 here is our a, -5 here is b, and plus 2 here is c. So let's just do that. So a is 6, our x1 then is -3. This is this x1 here. We have -5, which is our b, and then we have our y here, we've got to replace with y1, which is 7. Then we've got plus 2, which is our c. So that's our top line. Bottom line then is going to be the square root of our a squared plus b squared. So we take a 6 here and we square it, so I'm just going to put 6 here, square it, plus the b here, which is -5. I'm going to square that. Okay, so we're just going to do all of that then, and that's our distance. Okay, so on the top then we end up with the modulus of -18, 5 7's 35, so that's -35. We've got plus 2 here, and then on the bottom we end up with the square root of 61. So 6 squared 36, 5 squared 25, so 61. Okay, so let's do that. I'll just move over here. So on the top line we end up with the modulus of -51 divided by the square root of 61. So the reason we have this modulus symbol here is, or absolute value symbol here, is because you can't have a negative distance. So it has to be positive anyway, so this will make everything positive. So when you do that, you actually get 51 times the square root of 61 over 61. If you type this into your calculator, this is the way. So you can, you can write this to 2 or 3 or 4 decimal places, whatever way you're asked for in the question. But this here is effectively our distance. Okay, let's do another example. So that's a straightforward example where you're given a point, you're given the equation of a line, and you just want to find the distance between the point and the line. So let's have a look at another example where you can use this formula. So let's say we have 2 parallel lines. So let's say we have 3x -4y plus 10 equal to 0. And we also have 3x -4y, 3x -4y plus 15 equal to 0. Now both these lines are parallel. And what we want to do is find the distance between these two lines. So what we can do is find a point on one of the lines and then find the distance between that point and the other line. So let's say we call this A and this B. This is line A, this is line B here. So if we have a look at A here, just line A, let's find a point on that line. Well, the easiest point to find is where either x or y is 0. So let's take x is equal to 0. that will give me, let's see, 3 times 0, which is just 0, minus 4y plus 10 equal to 0. So that will give me minus 4y plus 10 equal to 0, which is minus 4y is equal to minus 10, or y is equal to 10 over 4, or minus 10 over minus 4, which is 10 over 4, which is just 5 over 2. So if x is 0, y will be 5 over 2. So this point is on our line A. So all I've got to do now is do exactly what I did in the previous example and just find the distance between this point here and B, the line B. Because remember, these two lines are parallel. So if one looks like this and the other is like this, if this is A and this is B, we found this point here, 0, 5 over 2 on this line here, and all we got to do is find the distance, perpendicular distance between that point and B. So let's just run through that quickly. So D is going to be equal to, I'll just write the equation down. It's going to be ax1 plus by1 plus c modulus over the square root of a squared plus b squared. So let's see, our equation of our second line B there is 3x minus 4y plus 15 equal to 0. So in other words, A here will be 3, B is minus 4, and C here is plus 15. So this is C, this here is B, and A here is 3. And our point is, let's see, what was our point again? It was 0, 5 over 2. So the point is 0, 5 over 2. So in this case then, 0 will be x1 and 5 over 2 will be y1. So all you got to do is put all of this into this equation here and work it out. So what do we get? Let's see. The modulus of a, which is 3, x1, which is 0, plus b, which is minus 4. Let me just put in a minus 4 here. So it's going to be minus 4. And then our y1 is 5 over 2. Then we'll have our plus c, which is plus 15. All of that over the square root of our a, which is 3 squared, plus b, which is minus 4, and that's squared. Okay, so let's just work this out. Let's see, 3 zeros, 0, so we end up with 4 5 is 20, divided by 2 is 10, so we end up with minus 10 plus 15, and then on the bottom here, well, this is just your standard Pythagorean part of it anyway, Pythagorean triple. So this is just going to be 3 squared, which is 9, 4 squared, which is 16, so that's 25. Square root of 25 is just 5. Okay, so if we do the top line, we end up with the modulus of 5. On the bottom we end up with 5, so that's just going to be 5 over 5, which is 1. And that's it. I'll do one more example, and we'll leave it at that then. So let's see. In this particular case, I'm going to look at, let's take minus 3, minus 4. This is a point. Now what we want to do is find the equations of lines that go through this point here that are a distance square root of 10. So this is our distance, square root of a 10 from another point, which is 2, 1. So in other words, we have this point, let's say minus 3, minus 4 here. So we have minus 3, minus 4 here. And we have our point 2, 1 somewhere. So there are lines that go through this here. Two lines we're going to say. Let's see, I'll just draw these. This is just a rough sketch. So there's a line that goes through here, and let's say there's another line that goes through, whoops, the idea, let's see, let me just do that again. So it goes something like that. So we have two lines that go through that, and we have a point here, let's say 2, 1. I'm not drawing this very accurately, but you get the idea. This, let's say this point here, let's say is 2, 1. And the distance from these two lines, the perpendicular distance here, is the square root of 10 and square root of 10. Okay, so obviously 2, 1 wouldn't be over here in relation to minus 3, minus 4. It would be probably up here somewhere, but you get the idea anyway. We have at least, well, we have two lines here that are a distance, a square root of 10 from this point to 1. So what are the equations of these two lines here, these two red lines? Well, let's just work that out. Well, the equation of a straight line is going to be y minus y1 is equal to m times x minus x1. That's the equation of a straight line. Now, we know that this line here, these lines here will go through minus 3, minus 4. So in other words, we've got y plus 4 minus minus 4, in other words, which is plus 4, is equal to m into x minus minus 3, which is plus 3. So if I multiply that out, we get y plus 4 is equal to mx plus 3m. Put that in standard form then, let's see, put the x first, so we'll have mx, bring this y over here, or subtract y from both sides, so that's minus y, bring this 4 over here, or subtract 4 from both sides, so we'll have 3m minus 4 equal to 0. Okay, so this is the equation here. This is the equation of any line that goes through the point minus 3, minus 4. So this will be the equation of of any line here, any of these lines here. Okay, now we know the distance. We know the distance of this line here from this point here to 1. So, and we know it's root 10. So I'm going to use my formula that I used earlier to write an equation using this and using root 10 and using 2, 1 to find the slopes, to find m. And once I have m, all I've got to do is put the values of m in here, and that'll give me the equation of my line. So we got to work out m. So let's write down our distance formula anyway. So again, d here is going to be equal to the modulus of ax1 plus by1 plus c all over the square root of a squared plus b squared. So let's just write down what a, b, and c are again. Well, a in this case is just going to be here, the coefficient of the x, which is m. B here is going to be the coefficient of the y. In this case, it's minus 1. C here is just going to be whatever's left over here without the x and y. So it's just going to be 3m minus 4. Now we also need x1 and y1. Well, x1 is just going to be 2. That's the point, remember? The x-coordinate of the point. And then y1 here is going to be this value here, which is 1. So now I have everything I need to go into this formula, including, remember, the distance here. D is root 10. D is root 10 here. So let's put all of these values in and work out a value for m. Okay, so d here is root 10, so we'll put that in on the left hand side. Let's do this in white. So let's say root 10 here on this side. Okay, so we want a then, so that's going to be m times x1, which is 2. Now we want, let's see, plus b, which is minus 1. Okay, so let me just put a minus in there. So just leave that at minus 1 times y1. So y1 is 1. That's fine. Plus c, so that's going to be plus 3m minus 4. So all of that is going to be over the square root of a squared plus b squared. Well, that's just going to be m squared plus b squared, which is minus 1 squared. Okay, so you can see here we have an equation. The only unknown, the only thing we don't know in here is m, so I can isolate that m at some stage. Now, let's just keep working through this. What I'm going to do is multiply across here, multiply across by the square root of m squared plus 1 squared here. So if you do that, you get square root of 10 times the square root of m squared plus, this is just minus 1 squared, which is 1. Okay, on the right hand side then I get the modulus of 2m minus 1 plus 3m minus 4. Okay, let's just multiply this out here, and you can see here that you have two square roots here multiplied, so we can combine them if you like. So you end up with the square root of 10 m squared plus 10. Just multiply these two terms, these three terms here, in fact, 10 by m squared, 10 by 1. Okay, on the right hand side we end up with the modulus of 2m plus 3m, that just gives me 5m, and then minus 1 minus 4, that's minus 5. Okay, so now what I'm going to do is, let me see, what will we do? We will square both sides. Square both sides, okay. So if I square the left hand side, I get 10m squared plus 10. On the right hand side, well, I just got to do all of this. Let me see, what is it? 25m squared minus 50m plus 25. You can do that yourself. It's just 5m minus 5 times 5m minus 5. That's what I've done. So you can do that out yourself. So it's the this is what you get when you do that anyway. Okay, so let's just bring everything over to one side. Remember, because we squared this here, this modulus, the modulus signs disappear. Okay, so because everything squared is positive or equal to 0. So let's see, we'll bring everything over to one side. So let's see, we've got 25m squared minus 10m squared, so that gives me 15m squared. We've got minus 50m. We've got plus 25 minus 10, so that's plus 15. Okay, so let's divide across by 5. Divide 0 by 5, you get 0. Divide this by 5, you get 3m squared. Divide this by 5, you get 10. Divide this by 5, you get 3. Okay, now let's just solve this. So we got to factorize this then. So 3m squared, that's going to be 3m times m. 3 times 1, well, I'm looking for 10 here, so I'm going to put the 3 here and the 1 here. This is a plus, so it's going to be plus plus or minus minus. This is a minus, so I'm going to do minus minus. So this works anyway, so let's just, oops, I'd actually leave that out. I'll just skip a few lines here. This means that, okay, so 3m minus 1 is equal to 0, or m minus 3 is equal to 0. So that finally gives me an m of 1 over 3, or m equal to 3. So now I have two values for m here, so all I've got to do is substitute these back into the original equation. So remember this, where did I put that equation now? Let me see. It's this one here. This is the equation of the line that passes through the point minus 3, minus 4. And we actually have two lines. So all I got to do is put one of my m values in here and here. That'll give me one equation. Then put the other m value in here and here. That'll give me the other equation, the other line. So let's do that. So they're my two m values. Okay, so let's see. Our equation was mx minus y plus 3m minus 4 is equal to 0. So let's just put our values in. So equation 1 then. Equation 1 then is just m, which is 1/3 x minus y plus 3 times 1/3 minus 4 equal to 0. So if we do that, we get, let's see, what I'm going to do here actually is multiply across by 3 just to get rid of this third here. So let's see, multiply this by 3, you get x. Multiply this by 3, you get minus 3y. Multiply this by 3, you'll get plus 3 minus 4 equal to 0. So we finally end up with x minus 3y plus 3 minus 4 is just minus 1 equal to 0. This here is one of our equations. Okay, so the other one then, 3, okay, so the other one, sorry, equation 2 then. Equation 2, so it was, sorry now, let me just go back here a second. Oh yeah, it was m is equal to 3. So we've got to put 3 in here then. So we've got to put 3 in. Okay, so 3 is just going to be, let's see, 3x minus y plus 3 times 3 minus 4 equal to 0. So this will give us 3x minus y plus 9 minus 4 equal to 0. So that will give me 3x minus y plus 5 equal to 0. This is the second equation then. Yeah, so these are our two equations. So these are our two lines. Remember, these are the equations of both lines. The equations of both lines that pass through the point minus 3, minus 4, and both lines happen to be a distance of root 10 from this point here to 1. Okay, so that's it from a fairly straightforward example to, you know, one or two different types of questions that you could possibly be asked. There are many other types, but you'll just have to kind of deal with those using this equation here as you come across them.